when we're reading the solubility curves, so they will all be given to us on some kind of graph that specifies an amount of grams of your solute. So in this case, all of our solutes are dissolved in 100 grams of water and a specific temperature. The important thing to note is the first step when looking at any of these graphs is to identify which substance it is that the question is actually asking about. So if we're going to classify it as saturated, unsaturated, or supersaturated, I first need to know what substance or what line I'm going to be looking at. So for this one, I'm looking at sodium nitrate. So what that means is that once I find the line for sodium nitrate, that is the only line on this entire graph that matters. So I'm going to highlight that, circle it in purple, and then I'm going to find the line for sodium nitrate, which is here, the curve for it, and highlight that in the same color. So once you've identified the line that matters, every single other curve on the entire graph effectively doesn't exist for this question. And then what this is asking us is 80 grams of NaNO3 dissolved in 100 grams of water, which is what the graph is made for, at 10 degrees Celsius, is that going to be saturated, unsaturated, or supersaturated? So I need to find the point where all of those things meet. So again, keeping in mind that this 100 grams of water is just how the graph is made, so we can pretty much ignore that part. I find where 80 grams intersects 10 degrees Celsius. 80 grams of my solute is somewhere on this line, and then 10 degrees Celsius will be somewhere on that line. So right here is where they meet. I know it's not super precise the way that it's drawn, but that is close enough that I would call it on the line. So really when you're looking at these, you are looking at, is it above the line, on the line, or below the line? Since this point where 80 grams and 10 degrees intersects is pretty much spot on the line, I would call that a saturated solution. So the line will indicate where something is saturated. So it is on the line, which means it is saturated. I'm going to change colors for the next one just so that it doesn't confuse you. So if I have 60 grams of potassium chloride in 100 grams of water at 70 degrees Celsius, again, my first step is to find the line that corresponds, the curve that corresponds to potassium chloride. So that would be here. So if you have a highlighter, I would recommend highlighting it. 60 grams in 100 grams of water, so this is already taken care of there, at 70 degrees Celsius. So I look up my 60 grams, find 70 degrees Celsius, and then mark the point where they intersect. So that would be here. So when the point that is described by the question is not on the line, that means that you do not have a perfectly saturated solution. The way that we read it is that this entire area above the curve, for whatever substance it is that you're talking about, so the area is going to be different depending on which solute it is. That entire area is what we would call a supersaturated solution. So any point above the line is going to be supersaturated, and any point below the line is going to be unsaturated, under the line unsaturated. So is this point, does it fall into the supersaturated or the unsaturated area? Supersaturated. Even though it's on the line for ammonium chloride up here, that's not the substance that we're concerned with, so it does not matter at all that it's on that line. So it is a supersaturated solution because the point that's described by the scenario in the question is above the line. I keep saying line, but it's the curve. The curve for whatever that solute is. Most of them, like this one looks pretty straight, so that's why I call it a line. So it is above the line. I guess a curve is a line, right? Above the line is supersaturated. Then I'm going to change colors again for my next one. If I have sodium chloride, NaCl, what is my first step? Find the line. Identify which line it is that's going to identify the solubility of that solute. So that's this one. then 35 grams in 100 grams of water is going to be like somewhere between 30 and 35, and then, sorry, somewhere between 30 and 40, and then 90 degrees Celsius is here. So up, find the 30 line, and then go halfway. So like here. So again, this entire section below the curve or below the line would be unsaturated. So since that point falls within that section, that's going to be under the line. I would call it what?
Unsaturated.
Perfect. Make sense? I'm like hoping, there's a lot of questions that involve solubility curves on your test. I'm really hoping that it's like slam dunk, easy questions for you to answer. We can make it a tiny bit more difficult just by changing the wording. What tends to throw students off is not paying attention to which line it is that they're looking at and overthinking the units that are on the graph. And so in the question it says, what's the maximum amount that will dissolve in 100 grams of water? And then they try to do some kind of math to figure this out. But all of these are in 100 grams of water. So that's why I keep pointing that out over and over again so that you're familiar with it and used to seeing that. So it says, what is the maximum amount of KNO3 that will dissolve in 100 grams of water at 65 degrees Celsius? So my first step is find the line that is associated with that solute. So for KNO3, that's going to be this. The maximum amount would translate to a saturated solution. So I need to find saturated solution, which means that I'm going to be on the line. So this question is effectively asking, at what point is 65 degrees Celsius on the line for KNO3, or what amount of solute can dissolve at that temperature? So I'll go to 65 degrees, which is going to be halfway between 60 and 70, up here. Okay, so it would hit this line where? At 120. So my answer would just be 120 grams of KNO3. So it's just about reading the graph. There is no math involved with this at all. And then number 5 says, at what temperature will 72 grams of hydrochloric acid, HCl, completely dissolve in 100 grams of water? So this question kind of requires a little bit extra just because of the way that it's worded. Use like orange. At what temperature will this much completely dissolve? What type or types of solution will completely dissolve the solute? Saturated. Anything else? Is the solute completely dissolved in a supersaturated solution?
Oh, wait, no.
No. But unsaturated, yes. So saturated and unsaturated. So I think maybe it should say temperatures, because I would say that this needs to be a range of temperatures that would allow that solute to completely dissolve in the solvent. So saturated and unsaturated solutions would both have completely dissolved solute in them. So then I would go find hydrochloric acid, HCl. And this curve is a little bit different. It goes down instead of going up, which means as we're heating it, we're able to dissolve less and less solute. So I'm not sure in this case if it's supposed to be a gas. Like some of them, I think the curve goes down because they're gases, and so the solubility decreases as you increase the temperature. HCl is hydrochloric acid, which I've never seen as a gas, so I'm not sure why that one goes down, but it does. So then I would go to 72 grams, which will be just above 70, and then see where this intersects the line, and that will at least give me my starting point of a saturated solution. So I would say like right here, or at least really close to it. What temperature would we call that?
20.
20. So then I would say 20 degrees Celsius. And then again, to give us that range, it's either going to be 20 degrees Celsius and below, or 20 degrees Celsius and above of when it's going to be dissolved. So if an unsaturated solution is going to be the entire area underneath the curve, does that mean I need a low temperature or a high temperature?
Oh, low temperature. High temperature. Any. Oh, wait, no.
No, for this specific example, to dissolve 72 grams of HCl.
Oh.
If you're not sure, you can like just guess a random one. Okay, so if I had,
Low temperature.
yes, so 72 grams of hydrochloric acid. If I increase the temperature at all over 20 degrees, I'm in the supersaturated area. So that's not all going to dissolve. So 20 degrees or less is going to keep that 72 grams of hydrochloric acid dissolved. So 20 degrees Celsius, I don't know why I put the C like that. Sorry, that's weird. 20 degrees Celsius and below. Or you could say less than 20 degrees Celsius. Something like that would be adequate for answering that question, just to show that you understand that both a saturated and an unsaturated solution will have completely dissolved solute.